All right, so let's keep rolling from where we were last time. Make this a little bit higher. All right, so where we left it at the end of class last time is effectively the completion of the previous assignment with no real um, logic to it. So if we hit play here, we see our Pac-Man guy. He heads to the north, comes in from the south, then just keeps repeating over and over and over again because he's always heading to the north, hitting that thing, so on and so forth. All right, and if you remember, we have some code that's doing that logic. So let me just get that code back open here. So remember that we had in our singleton the current direction. We started off at the question mark. So when a player first comes into existence, when the start function gets called, we ask if the current direction is not a question mark, then we're gonna then it must be something else. So we're gonna go ahead and check, is it equal to north, since we know that's the only direction that it currently could be. And we're going to set this guy's transform position to the position of the south exit. If you remember, we put north, south, east, and west exits in here. So right now, when our player is heading towards this north exit and he collides with that, remember we put a box collider on that guy, it will come into the start at the south exit's location and keep doing whatever it was told to do inside of update, which right now just says go towards north. All right, well, in our game, we probably don't want that to do that every single time. We want to have some level of control over this. So we're going to go back into the code here. And notice we have our on trigger thing for that collider. So if we just collided with a door, we're going to set our current direction to the north. That lets us know where we just came from. And then we'll load our dungeon room scene. Keeping in mind that when the dungeon room scene loads again, this player will be born again. His start method will get called again. And this guy says, is the current direction not equal to a question mark? It currently is not equal to a question mark. So what are we going to do? We're going to, if it's equal to north, we're going to position him from the south. And we see that happening here. So as soon as he hits the north and we change scenes, now he comes in from the south. All right, so back in the code here, inside of update, what are we doing? We're always moving towards the north exit. So no matter which version of the player script we have here, the version of the player script that's running on our first scene, or the version of the player script that's running on our second scene, or our third scene, or our fourth scene, so on and so forth, the guy's always going to be heading towards the north. Now, we probably don't want this to actually always go north. We want to have some sort of control over this. All right, so we're going to have some control over it with the arrow keys. So we're going to respond to some key presses. So we'll go back over here and we see that we have this input class and we have something called get key up. So we could ask the question, for example, if input.get key up, so input's the name of the class, get key up must be a static method of that if we're calling it with the class name itself. And then we can tell it the name of the key. Now, you can either put the string version of a key in there. So for instance, if we just steal this exact code here, I'll go ahead and throw this into my update function for no good reason. All right. So whenever we press and release the space key, so this is getting the key up. if we release the space key during this call to update, which happens every single frame, we're going to print the space key was released. So go ahead and run that. We have our console up. So there's me hitting the space key. All right. Now we want to respond to maybe the arrow keys, if that's how we want to control our dude. So in order to get the string for the arrow keys, we could either, I mean, I'm guessing it's maybe up. I mean, we can even take a guess at that if we want to try up. So instead of space, maybe it's called up. I'll go ahead and save that. We'll go and try to run it, and let's see if it's responding to the up arrow. Oh, it is. So I guess that was a good enough guess. But I'm going to say that's probably not great programming practice, especially if they might change the name of things in the future. So we can actually use the key code class, and the key code class has a bunch of static variables in it. For instance, one of them is called the up arrow. So inside of here, I can say if input.getKeyUp keycode.up arrow. So if I just pressed the up arrow, what do we want to do? We want to start heading to the, where am I moving towards? To the north. All right, so we're going to do an else if. We're going to see some challenges we run into here. We could actually do these as a bunch of ifs rather than else ifs if we want. So if we press the down arrow, do this, left arrow, do that, and we'll go in and fix up the right arrow. Do this. And instead of our north exit, this guy will go to our south exit. This will go to our west exit. This will go to our east exit. All right, so we're only going to move in a direction if we press a arrow key. All right, now currently this is only going to be moving in that direction when we press the up key. So let's kind of see what that behavior looks like. So we're only going to be moving towards a destination if during that particular frame we pressed the key up. So this is going to give us kind of an interesting behavior. I'll go ahead and hit play here. So I'll press the up key. I'm pressing it over and over and over again. You see how he's just inching forward ever so slightly. And I'm going to press the left key and notice how he's kind of going down at an angle ever so slightly. You know, we can increase our speed if we want him to jump by a little bit bigger margins, but he is moving as a response to that. What we really want to have happen here, though, is when I press the up key, we want to have him in motion, heading towards a direction. Okay, so what we're going to do here, inside of our singleton, we want to keep track of the current direction we are heading. Okay, so we'll keep track of the current direction that we're currently heading. And when we first press the up key, we want to go ahead and, let's say, set the current direction to north, for example. So let's go back into our code here, into player. So when we press the up key, we want to say the current direction is equal to north. Similarly, We press the down arrow, we're going to head to the south. Left arrow, we're going to head to the west. Right arrow, we're going to head to the east. Okay, so now I'm just going to cut one of those lines. We're going to rewrite those. So these if statements, all they do right now is they update a variable in our singleton, which is the direction we should currently be heading. All right. So now we're going to say, make the player move in the current direction. So we're going to say if my singleton dot current direction dot equals north, we'll go ahead and have him move towards the north. South, we'll have him move towards the south. West, we'll have him move towards the west. And east, we'll have him move towards the east. All right. So on any given frame, if we pressed up on the up arrow, so we let go of the up arrow key, it's going to let our singleton know the direction that we intend to head. So if this particular frame passes and we did any of those four things, including all of them, if we have multiple keys pressed, that is going to lead to some other weird behaviors, but let's just take it one step at a time. So regardless, so if we press one of those four keys, we're going to be updating our global variable inside of our singleton to a direction. Now, inside of update, we're also going to be asking some question about the direction we're currently heading. If we're currently heading north, if our singleton says we're heading north, we're going to be changing our position for our player to head towards the north exit, south exit, west, and east, so on and so forth. All right. So I'll go ahead and save that. And now let's see that behavior. So right now he should be sitting there by himself. I'm going to press the up arrow. So now he is going. I'll go ahead and press the down arrow now. I'll press the up arrow again. I'll press the west arrow, east arrow. Okay, so we can move around now, sort of. I can't get my guy to stop, but I can move around sort of. Okay, now we notice that right now only the north exit gets us to its opposite. And that's because we only have the collider on our north exit currently. All right, but before we go and fix that, we probably want our player to face in the direction that we want him to, that he's traveling in. So that means we're going to need to do a rotation on him. So when I go to head north, I think I have that page open here too. Is it this one? So one thing we have inside of vector 3 is something called a rotation. All right, so we can rotate towards with a vector 3. We can also, there's some other ways of rotating as well. So rotating says, what's our current rotation? Where are we going towards? The maximum angle in radians allowed for this particular rotation. So if we wanted him to rotate quickly, we would put this as a very high number. well, actually the delta, the change in magnitude would be a high number. All right, so this would have him rotate over time towards that position. So let's just see what that looks like for when we go south. So if we press the down arrow, we're going to say vector 3 dot rotate towards. Now notice this guy returns a vector 3. So we're going to be updating this dot game object dot transform dot rotation. Okay, so first of all, you see we have a couple of other things here. We're going to look at those in a minute, but for right now, we're going to say we're going to update this game object's transform rotation to whatever vector 3 rotate towards returns for our current rotation. So this dot game object dot transform dot rotation, and then where we're going towards, which is this dot south exit dot transform dot rotation. And next thing is max radians delta. So this is in radians, not degrees. So they're saying a single, let's see, target direction, single step, and then this just moves it by one step with a 0. So let's just look at that a little bit. So we're going to say for single step, what's 90 degrees in radians? Pi over 2. So that's 1 point, let's just say 1.5 F. And the speed, we're going to, well, we'll do this over time dot delta time. And we'll just multiply that by this dot speed. Oh, it wants the vector 3 of that. Okay, so this is something I'd mentioned to you before. So notice here that what I put in for the south exit, so if you look at this guy, he's taking a vector 3, so rotate towards is where he currently is, where he's going towards, how much we're willing to rotate at a given point in time, and how much we should do this particular slice of time. Now, what I've put in here is the vector 3 associated with the rotation for our game objects. Now, the reality is that rotations are actually not vector 3s, they're quaternions. So I had mentioned to you before that quaternion math is kind of rough. So what rotate towards does is it does the math for us. So I can say we are currently at this position. Let me make sure that that is the correct input for that. All right, so rotate towards, I think we can give it the current position. We want to rotate towards this position. And then ultimately, this guy is going to return a rotate towards, where's our function for what he returns? He returns a vector 3. Now again, so this vector 3 is the kind of the direction we want to be facing, but it doesn't represent an actual rotation because rotations are represented in quaternions. Now, there are some tools in here. I think it's in the quaternion class. Quaternion dot. I think there's a way to, let's see, rotate towards. That's not going to help us. Lerp. Also requiring quaternions. there's a way to map a vector 3 to a quaternion. Probably not going to give us what we are ultimately looking for there. All right, so punchline here is that this vector 3 spits out a quaternion, and a quaternion is a mathematical vector, but it's not a vector 3. So we'd have to convert that quaternion into something else. All right, so maybe rotate towards is not actually the thing that we want. We saw a second ago that we do have a, where was the function? We can rotate about an axis. Let's look at that. So it is this dot game object dot transform dot rotate. So we're going to use the transform itself. So first of all, here's an interesting thing. I can tell it to rotate. So we have a rotate function here where I have to give it Euler angles, and relative to whether it's space or a local area, blah, 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 I can rotate around a particular axis. So either the y-axis, z-axis, whatever. I can do a local rotation, but here's an interesting thing we can do, and it's called look at. So we have a function called look at that allows us to rotate the transform of this thing so that the forward vector points at the target's current position. So we can just say, look at something, and it will turn to face that. All right, so let's look at what that does if we put that up in our if statements with our, well, here, we'll put it right here in our south. So we're going to say dot look at, and this guy is expecting a target, and the target is going to be this dot south exit dot transform dot position. So as soon as we press the down arrow, we're going to set our singleton's current direction to south, and we're going to tell our game object to go ahead and look at the south exit. Not rotate over time. Rotating over time is something you might want to do, but you saw there that you start getting into that quaternion math, and then you have to go and look at the classes that allow you to handle kind of slow rotations and things like that, as opposed to a snap rotation. So if I press down, notice he started, he's facing the down arrow now. I didn't update it for the other arrows. So look at kind of accomplishes what we want. Now I can steal this and say, if we did north, we want to look at the north exit. If we did west, we want to look at the west exit. And if we looked at east, we want to look at the east exit. All right, so now our guy should be able to look at all the different exits. So first of all, notice kind of a weird behavior here. So he can look at each of the exits, and ultimately he can make it to any of the exits, right? But if we get going too far, notice that he just angles towards the exit we want to go to, which is kind of maybe a fun. So we're using move towards to just head in that direction at an angle, and we're using the look at to make sure we're looking where we're going. So this is a reasonable enough look. One problem we have with this for this particular game is our idea is that we kind of come to the center of a room. And this doesn't have to be the idea for the game, but this is the way I was kind of angling towards, is when we come to the center of the room, and I start saying going north, once I've locked into going north, that's it. I can't change my mind on this room. All right, so once I hit north, I'm committed to that direction. And once I go through the north door and I come in on the south, I want him to kind of stop here at the middle of the room. Okay, so what we need to do is we need to create some way of making this guy stop. All right, before we do anything else. But we also need to make it so that it's prohibitive for us to change directions at the last second. Once we're going in a direction, we need to stick with that. All right, so let's get a couple of those pieces working here. So we're going to add a little bit to our code up top here. Right now, we say if we're not heading if we're heading somewhere in a certain direction, we want to change our position. So we're going to say else if we're currently heading south, we want our guy to come in through the north exit. We'll position him there. Else if we're heading west, we're going to have him come in the east exit. And if we're heading east, we're going to have him come in the west exit. All right, and this gets called one time when a scene first starts. So the current direction we're heading gets set when we press a button. So if we press the up arrow, we set the current direction to north. Now, as soon as this script loads fresh again, which will happen once we have collided with a door and reloaded the scene, which gives us a brand new player with his, notice we're currently, we have north hard coded there, but we can take that out right now because we're updating the way it works at the moment. So once we hit a door, we want to reload this scene. And when we reload this scene, what we're going to end up with is calling the start function again, because we're in a brand new scene with a brand new player who has a brand new player script. He's going to go ahead and check what the current value is in the singleton is. So this is him talking to that singleton. So this is scenes communicating with each other. If I was heading to the north, I'm going to position myself at the south. If I was heading to the south, I'm going to position myself to the north. If I was heading to the west, I'm going to position myself to the east. If I was heading to the east, I'm going to position myself to the west. All right, so let's see that occur. Now, one thing to keep in mind here, though, is right now we only have an exit. So if we click on the north exit there, notice this guy has a box collider, but none of the other exits have that. So I need to go ahead and I can select all three of these guys. I can add a component. I'll add a box collider, and that'll add it to all of those other three. I'll go ahead and make that box collider a trigger because we don't want physics to act on that. We just want it to hit it and for us to be able to programmatically deal with it. And then we're going to go ahead and tag it as a door. All right, so when it hits any one of these four doors, it will trigger the code getting called that there was a collision, and it will be tagged as a door. All right, and keep in mind that inside of our code, when we enter a trigger, if that trigger was a door, we want to load the scene again, which should then ask the question, where were we heading, and put us in the right place. Save that, come back out here. So now we should be able to run around our dungeon. So there's to the north. Oh, that's kind of an interesting thing because he's actually hitting the trigger again. So he entered the trigger here. which then loaded the new scene, positioned him in this bottom scene. So what's actually happening here, if you look in the upper left, it is loading this scene over and over and over again because he is entering through this this door, which causes the on trigger enter. All right, so we kind of have built in an infinite loop into our game here where we can't actually get back to the middle of the room. All right, so what needs to happen here is as we are leaving the room and we enter this trigger, it's going to put us in this other side, but we probably need this guy to be disabled for now because we don't want him to accidentally collide with a trigger until he's probably back to the center of the room. All right, so this is kind of the direction we're going here. We're going to put a collider here in the middle of the room that allows us to kind of turn that back on. All right, and I think you'll see how that works here in a few minutes. All right, so we don't want this to keep going. So by default, we want to have our doors turned off. So we have these 4 exits, and we have access to those 4 exits here in our code. So the very first thing, and I'm going to go ahead and write a separate function here. So we're going to write a function private void turn off exits. And what this guy will do is it's going to disable north exit dot game object dot, what is it, active. Is it set active? Set active to false. So let's just start with this. North, south, east, and west. All right, so when a scene first starts, the very first thing we want to do is we want to turn off the exits. All right, that way, when we position ourselves in the correct place, it will realign us and keep us heading somewhere, but we won't re-hit the scene. But one issue we have here is that we also won't collide anymore. So just for the testing here, I'm going to turn off us disabling the north exit. That way we can still hit it the first time, and we'll see that we fixed the problem with the south exit. So this is a temporary solution just for testing this premise. All right, so we'll do that. I'm going to press up. Now, right now, the north exit up here is still enabled, but all of these other exits are turned off. So we'll hit that guy. He comes in on the bottom. Okay, so we get the behavior that we wanted, but if I go left, now we see that we no longer have those exits on. So we need to have a way of making sure we enable a certain exit if that's the direction we're currently heading. All right, so that's going to happen when we hit those arrow keys. So let's go ahead and disable the north exit again. So just by doing that, just to show you that now we won't be able to reload our scene because a collision never actually occurs. So when I head north, it goes there, head south, it goes there, but we're not colliding with anything because it's not real. All right. So now what I'm going to do is I'm going to have a duplicate function here, but we're going to have this guy called turn on exits. Now you could have also written something like toggle exits and maybe taken a Boolean true or false in here. But we'll just do this so that the function call doesn't require extra parameters and just does what we want it to do. So turn on exits will set all those game objects back to active. So if you want to disable, well, you saw this in the original tutorial, when you picked up one of your things in the rollerball, you set its active state to nothing. So it would disappear from the scene. All right. So now, as soon as we hit one of our arrows, whether it's the up arrow, the down arrow, doesn't matter, we want to go ahead and say this dot turn on exits. All right. So this allows us to make sure we can collide. We're still not where we want to be yet, but as soon as we hit one of the keys, up, left, the up arrow, right arrow, whatever, we're going to let those exits turn back on so that we can collide with them. Even though when the script first starts, those exits are turned off. We turn off the exits right here, the beginning of start. So we can put a little comment, disable all exits when the scene first loads. And then we enable the exits as soon as we hit an arrow. All right, so this should get us a little bit closer to what we're trying to do. So I'll press up, we can go there. All right, now I never pressed an arrow again. So since I never pressed an arrow again, I'll just show it here. So I went down, I hit the, oh, here, I gotta load it again. So when I hit the up arrow initially here, it's gonna turn all the exits on, turned on. But now the exit's turned off. Now it's back on. Now it's off, back on, off. So I'm going to leave it off here. So you're going to see it hits. So we only toggle the exits from off to on when we hit an arrow. And keep in mind that whenever we hit an exit, we load a brand new scene where everything's disabled again. All right. So if all I do is press the arrow one time, press left, it'll go through there, but now all the exits are disabled because this was a second scene being loaded. All right. So this sort of kind of gets us the behavior we're looking for. But what we don't get here is if I'm heading up and then I say left, we do fly in right, although we're kind of twisted, twisted funny from a directional perspective. We need to rotate ourselves. But what we don't want to have happen, what we don't want to allow, is when we're already heading in a direction, for us to be able to turn that direction or change our direction. Once we've made a decision to go in a certain way, we're locked into that. All right. So in order to do that, we need to add an additional constraint. This kind of goes way back to the very first class in 200, where how do human beings solve problems? We remember stuff, we ask questions, and we do repetition. So in this case, we want to remember whether or not we're already heading in a certain direction. And then before we allow us to go to a different direction, we want to ask the question, am I allowed to go in a different direction? Okay, so we're going to go back into our code here. And we're going to remember something. So we'll come up top. We're going to say private. Let's just make this guy a bool. Let's see. Let's call it am moving. And by default, we are not moving. I'm not sure I'm in love with that variable name, but we're stuck with it now. All right, so we're gonna, when a script first loads, we are not moving. So am moving will start off as false. So whenever we hit these, an arrow, come down here. If I hit the up arrow, I only want to change directions if I am currently not moving. So, and this dot am moving is equal to false, or I can say and not this dot and moving. So this says if I press the up arrow and am moving is currently false, then I can switch. Same thing's true here. Same thing's true here. Same thing's true here. So I'm only going to pivot if I'm not already moving. But now if I do start moving, I now need to, this dot am moving is equal to true. I'm moving now. So if I did hit another arrow after this, it's not going to let me in, because for an and to be true, both of these things need to be true. Okay, and not true is false. So as soon as I pick my direction, I'm going to label myself as moving from this script's perspective, so that if I try to hit another arrow while this particular scene has been loaded, it's not going to let me pivot my directions. So I'll start heading north. I tried to change my direction. Okay. So that gets us to that point. Now, what we really probably want to do is we definitely don't want to be able to change directions when we're currently in motion. All right. So when we're currently in motion, we don't want to change directions. But I'd also like to not be able to kind of travel at an angle. You know, in the ideal world, you can decide what makes sense for your game, but in an ideal world, I'm thinking what we want to be able to do is kind of come to the center of the room and stop. So whenever we're at the center of the room, our guy kind of is in, that's his default position. He's enabled to do his initial movement from that. So maybe we remember an additional thing. So maybe we say private bool am at middle of room. And we'll start that guy off at false initially. And that really is for the very first time that we come into the game, because we position him at the middle of the room the very first time. All right. So what we want to do here is we need to locate the middle of the room. So I'm going to give myself another empty game object here, just like we did with our other exits. So I'll create empty. And we're going to call this guy middle of the room. We'll go ahead and position him there. We'll just call that good. And then we're going to go ahead and add a box collider to this guy. We'll make it a trigger. Now, one thing you might find interesting here, you can mess with the size of your colliders. So for instance, if you find that this collider is a little bit small and you're not hitting it at the right way, you can make it bigger or you can make it smaller, you know, whatever it is to kind of get you the behavior that you want. So be prepared that sometimes you'll need to do a little trial and error to get your kind of guy moving the way you want him to move, or colliding with things at the right moments and not accidentally colliding with him at other times. All right. So now we have a middle of the room, and we want to maybe tag this guy. So we're going to add a tag. Let's call this guy middle of the room is our tag. I'll click back on middle of the room. And we'll go ahead and select that. So all of our exits are tagged doors. Our middle of the room is tagged middle of the room. this allows us to do different things depending on what we just collided with. All right, so tags are our way of kind of labeling those things. So now what we're going to do is inside of on trigger enter, if we hit a door, we want to do one thing. Else if other dot compare tag is how did I name it? Middle of the room. So if the thing we hit is the middle of the room, what we probably want to do then is set and that middle of the room to true. This dot am at middle of the room is equal to true. Now remember, this is only on trigger enter. Okay, which means that the very first time we come into the scene, presumably the way I have it positioned, the player is already sitting inside of that trigger. So I don't think on trigger enter will get hit. We can kind of prove that real quick by just doing print on trigger enter, something like that. And we'll go ahead and run this. We want to make sure that the very first time we run this, the player doesn't accidentally hit that trigger. Okay, and he is hitting it. So we probably need to position the trigger a little bit differently when we do this, or change the movement direction. So what we could do is say, if we are entering the middle of the room and my singleton dot current direction dot equals our question mark, which is what he started off as. If he's not equal to a question mark, then we'll go ahead and say I'm at the middle of the room. Okay, so the first time in, since we have not moved and we're at a question mark, this won't fire true because we are still at the middle of the we are in the middle of the room, but we don't want to allow for a collision with that right now because this is our very first time. All right, and current direction gets switched to like a north, south, east, or west when we do hit one of the arrow keys. So initially, I think we should be decent here. All right, so he is not colliding now. I'll go ahead and hit up. Oh, did he not hit it the second time? You'd save it, right? So we say aim at middle of the room is true. It starts off at false. We say if we hit the middle of the room and we are looking at something other than the equal sign, switch that to true. Oh, we're not printing it out, so we probably are doing that. Print at middle of room. We take it out of our print statement. Let's test this real quick so we're at a good stopping point. All right, so nothing there, but when he comes back into the room, now we're at the middle of the room, so he does detect it. All right, so now for your homework for Monday, bring your project up to this state where he's rotating to the correct places, but make your player completely stop in his tracks once he gets back to the middle of the room. So the behavior we want is each time we're in a scene, like when I hit north here, he comes in from the south, but when he gets to the center there, I want him to stop so that he's back in kind of the original position. Okay, I don't want him to just appear in that position though. I want him to enter the room from the south and get to the center and stop. Make some sense? Okay, so get your guy to the point where he's rotating to the certain places, whatever makes sense for your game. But ultimately, what we want to create is the situation where every room we go into, he eventually gets to a stop position so that we can now make a new decision of the direction we want to go. All right, questions, comments, concerns, bribes? All right, I'll upload this current version of the code. So again, you're just getting my scripts, but hopefully they're easy enough to follow. But I will see everybody on Monday.
Hey, Professor Lemon,
What's up?
I got a question. So I submitted to you my thing. I sent you a screenshot of my Unity for whatever reason when I logged into my project. It was like I was logged out of my account. So I was logged into my